Yeah, so hi, I'm Wintzer. I'm the Chief Product Officer at Noop. To give a little background and kind of, we just wanted to start telling you a little bit about what we do because you need to know like why we have this data to do this AI stuff. So we'll talk about that really quick. But yeah, I wanted to start with just kind of like talking about about our background and what we focus on. We've been, doing DevOps and cloud and data and security consulting in enterprises for years. We've helped lots of organizations set up their DevOps, their SRE, whatever flavor you want to call it, organizations. And we've always been striving, like our focus is like, this side of running software. There's a whole lot of stuff that people do about making software. Our passion and what we're really focused on is kind of helping people that write code and make software, like be able to just deliver it, to run it. And if you have any experience in that, it might resonate a bit that can be hard and frustrating. Some people say, engineers spend like less than 40% of their time actually making software, and the rest of the time goes into, fixing it and telling the operations team about it and, writing all the different config files that are necessary for your company's pipelines and everything else that, frankly, isn't value generating. The thing that generates your value is your software, not the way you run it. If there was, I remember a time early in my career when like running software included as part of my job working in a data center, that every month I had to go out to the backup diesel generator for the data center and pull out a dipstick to check to make sure it had enough oil. And like as an IT engineer, like that's weird, right? Like why do we, like that generates no actual value for you as an organization trying to make and deliver software. So we live over on this side of the fence, and we want to make something that basically does it all for people that make software. If your job is, if you're just like running an old server and keeping some 20-year-old application going, that's not exactly our forte. If you're making software and trying to compete in the software game with other people making software, the ability to iterate and the ability to move fast and with good feedback, with kind of flexibility in your software architecture is paramount. That's how you can build fast software better and faster than your competitors, not by having better diesel generators. Okay, so if you're at all familiar with the, close this little thingy here. If you're at all familiar, if you're in any kind of DevOps or SRE or cloud role, you might be very familiar with like the kind of current state of play in the industry is that, cloud is this enormous thing with thousands of tools available to you, and it's so easy. All you have to know is all 1,000 of them and how they integrate together and write a bunch of glue and scripts and customizations to bring all of these pieces together. Easy, right? This is why I love the most common debate I see like on Hacker News just at least a couple times a week is like, if you're a startup, you don't need Kubernetes, right? And that's not because Kubernetes is bad. It's because piling all these things up and trying to make a structure out of it is hard. It's not that the value that you get on the other end of it is bad. It's that like you have to do all of this. You have to go and pick all of these different tools and stick them together. And usually you end up having to hire, these are specialized things that are, complex in their own right. So in addition to hiring people to make your software, you're now hiring people to manage Kubernetes for you. Again, is it really that different than the diesel generator? So, we think that this space where the industry is right now of like, this is all DIY, everything, hundreds of different open source tools, and it's all really focused on infrastructure. If you've ever had the pleasure of writing a Terraform template, you might sympathize a bit here that like when you're speaking, developers don't speak infrastructure. They speak their software, their application, their software architecture. They want to run a service. They want to run a database migration. They just want everything to work. They want all the logs to be collected. They want it to be easy to gain insight into what's going on. And when you focus it on infrastructure, one, you generally can only run it in one place, which is pretty darn limiting. And two, it requires all this stuff kind of, all this stuff beneath here, like at your software, at your application level, everything beneath the application level, you have to take care of. And so we think that just doesn't particularly make sense. We were consult with a lot of big enterprises. We see everyone basically trying to build the same thing, just with their own bespoke arrangement and kind of eccentricities about what's allowed in their company and in their environment. But the kind of end goal and the value they're all seeking is pretty much the same. So we set out, a long time ago, before we got into consulting, we thought we were going to make this platform. We got into consulting and got occupied with that for a while, and learned a lot through that process. And we came back from that and thought that we need something better. We need something that isn't, just give a developer the ability to like do a CI/CD pipeline and a deployment. That's great, right? Like relative to where we were before. If you were doing software 10 years ago, like you remember like getting a server was like a turnaround time measured in weeks to months to like order a server and rack it, stack it in the data center and get everything on it. The ability to like push something out in your own organization through a CI/CD pipeline is great, but that's not the end of living with your software. Okay, your software does not just get deployed and succeed, and that's the end of your relationship with it as a developer to your software. There's a lot more to it. And so we kind of went through, and I encourage you all to check this out. We won't talk too much about it, but we put up our 12 expectations for developer platforms. It's at developer.app. And we were really focused on this end-to-end idea of what basically like what would be necessary for a developer to run their own software without a specialist for it, right? Without a specialist putting all that glue together and figuring out how your software runs across this big complex set of Lego bricks. So we created the Noop developer platform. We've got 3 kind of core areas we're going to focus on. We're really just going to talk about operations today, but just to quickly mention, we've got our Noop workshop is a local desktop application, free forever. You can download it now, kind of a Docker desktop replacement if you want to think of it as such. That lets you spin up a Noop application blueprint completely on your machine. It runs everything locally and consistently. So all the different, the idea is anyone that you're collaborating with on your software can git clone your software and spin it up in Noop Workshop. It doesn't matter if it's one service or 20 or a combination of different programming languages and static content and database migrations and different databases. All these different things are handled together and consistently because we take your application architecture and we can project it into the infrastructure of Workshop. Then you can go on to Noop Cloud, where we'll run a managed platform for you that, again, you can take your application architecture and push it to our cloud, and we will distribute it and run it with all the best practices we can in a hyperscale cloud and collect everything about it for you. And then we get into our operations role, and this really is kind of like a part that I think the DevOps world misses kind of completely out of hand. Like it's not even on anyone's radar for like, how do you make it better for the people that make the software? How do you make it better for them when their software has a problem? Right? Like when you have a problem with your software, how do you, like especially when it's 50 different tools that you've glued together, how do you gather all the information from those? Different people have different logins to them. This is where you end up like getting on a phone with the 5 people that manage all the different systems or in a Slack channel, and everyone just says, my stuff looks fine. And like, there's no holistic view to any of it. And it's basically human and out of band of the developer. So it requires specialized people sifting through Kubernetes logs to figure out why this thing didn't work. That's kind of silly to me. So we start with your blueprint and we go from your application architecture. We'll see a little bit more of this as we go forward, but kind of thinking about it the way a software developer does. I'm an internet endpoint and I have different routes for it that send traffic to different services and static websites and have different backend resources that have database migrations and all these things are defined together in your application blueprint to start. So that's really the core of where all of our magic comes from, because once we have that, we know how your app works. Right? If you have a Terraform template, you know what infrastructure you're launching. You don't understand how it works. That's where you engage your SRE to understand how it actually works or diagnose a problem with it. So Let's do a quick demo here and just start off with a little showcase of Noop. So we're starting off here, logged in with a sample account. I'm running all this, by the way. This is kind of some experimental AI builds that we're running locally here, just to be honest, that some of these AI features we're going to see are not deployed yet, but we want to give you an early preview. We're running under our demo account of my dog Watson, who's a very good boy. And let's go ahead and take a look in here. We've got a Watson's company, and we can see it starts off with a kind of high-level view of your organization, what's going on in it, what activity. Again, this was just launched, so it's pretty clean. And right now we've got one application, one endpoint set up. We can go here and take a look at the application. So we're going to play with this idea. We got a sample app we're going to play with called Clone GPT, doing an AI demo in an AI demo. And and we're just going to turn this on real quick. So let's go into our demo environment and just hit the on switch. And Noop's going to go through and pull that build, read the blueprint, and figure out everything it needs to do. So you see it's iterating through here pretty quickly. It's launching the services. We're seeing logs start populating. There we go, 13-second deploy. And we can go over here to our browser, and it's set up for us a local endpoint. So if you're on Noop Cloud, you can set up an internet endpoint, no problem. We manage certs, we manage everything for you out of the box. And let's just say hello. And there we go. We got a response from ChatGPT. So from there, we can see Noop starts aggregating. And we can see Noop starts aggregating information. We'll start seeing all of the traffic logs and everything about what's going on in this environment is consolidated and unified. And not only that, when you click on it, like here's listening on port 3000, right? Here we can get into the details of all the context that we've got, that we know specifically which container this was, what specific stack, as in what particular build it was. That'll come up later. We know which container it was. We know what source it came from. And so this is just your log, this is just your application console log listening on port 3000, easy peasy, right? But then also along with that, you see all these other structured events that we're populating in along with it. So traditionally, what would be in all the logs of all those different Legos are all unified here. So you could see everything about how it's building each container as it's pulled, as it's verified, as it's health checked, all the details of everything. You can see all the traffic being forwarded to it. So all the static content that was hosted out of it. Every request that comes in is decorated with context about what stream and what session it comes from, and you can easily filter down into all these things. So you can track down anything in particular you want. It populates our charts, it populates our graphs. All kinds of data visualizations are possible on top of our log data, and it becomes a principal thing we want to feed into the AI. Yeah. Oh, we got a question?
So the black box there, environment was shouldn't be infrastructure. If there was an application error, would you show up in that?
Yeah, definitely. We'll see that too. So this is what you would traditionally consider the infrastructure logs, and these are application logs here. So yeah, so this right here is just output of some module in this in this is saying, deprecated NPM module. That's just coming out of a node app. So everything's unified in there. And it makes it really easy as you drill into what's running in the environment. We can see this stack that's running. We can see what build is running of that, what source code that came from. We can drill into the specific components of it. And again, like logs start filtering. We can see logs for a specific service or a specific container of a specific service. We can drill down very, very easily into any of this stuff. So we can see we're on the chat API service that's part of this blueprint. And we can see that it's running one instance right now. And we can drill into that and see specifically everything, again, like down to what traffic requests are going to this container. Not the traffic requests going through your Nginx server or your load balancer. What traffic requests are going to this container of this service running this build. We know all of it. You didn't even open a terminal. And again, you can start seeing representations of the blueprints that we're using populating throughout here. Let me just jump back here and, whoops. Also, we can check out, the configuration of the environment, particularly it's got variables and secret management and everything built in. You can see we've got our OpenAI API key hidden here. Here I can even reveal it so you can see it. Don't worry, I'm going to delete this in a second, so feel free to try and copy it. And there's a little cooperate tab. We'll get back to that. With that, that's just a real quick crash course into Noop Cloud and what we're capable of. We can take a quick. Oh wait, yeah, let's finish up here with just talking about, like I said, logs. We've got everything unified together. Again, that context is like so important. Like if you're trying to gather out, even if you like go through the effort of paying someone like Splunk or Datadog a whole bunch of money to capture all your logs, and then you have to spend a whole bunch of time contextualizing it yourself so it can make some sense. Because if you just dump all the logs into a bucket, it doesn't know how any of them interrelate. So that context is just so important. I can't stress that enough. And one last little thing just to mention before we take a quick break, I want to introduce our AI cooperator. So, we thought about what, when we were kind of evaluating what, where AI was useful to us. That we really thought about, and we really were compelled by the kind of semi-unstructured data analytical capabilities of LLMs. We since we started the idea of like a platform, we were always really focused on like doing builds and deployments and pipelines. Like that's, we always refer to that as table stakes. That's the basics. You need that to get out of the gate. What's really cool for us is what we can do on top of that. Like what can we do when we have a unified thing doing all of this that knows from the time you check in, push some code to GitHub, that we know that it happened and that it should be built by this pipeline and pushed to this environment or made into a preview environment for you to test out a PR. Anything like once we kind of have all that built up, what useful value can we deliver from synthesis of it? And so LLMs became really compelling because we've got all these logs, but frankly, there's not a lot we could conditionally manually do about that, right? You can do trivial things like try and say every time the word error appears in your logs, increment a metric, and if that metric goes over this value, that's an alarm. Those are fun, but then we saw one the other day where what was it? Someone's application at the start of it output 0 errors detected, and it had the word error in it, so it counted as an error. It's just too dumb to try and capture and predict every type of thing you could want to look for in your logs. And that's where LLMs become really interesting to us, is that we can use the LLMs to analyze this semi-structured data. Again, we have this structure around context, but if your app outputs some new error you've never seen before, it might not be an error from your code. It might be an error from a library or a framework that's part of your code that your code is using. So how would you know to look for it or to monitor for it or to, anything like that? So, we really got excited about this idea of Coop and having the LLM step into kind of specific purposeful solutions at different points as you're running your software. So we'll get a little bit more into that in a minute, but we'll take a 5-minute break if anyone wants to get pizza or just talk about what we just covered. I'm happy to answer questions. I mean, at least some, right? Like we're going to show a demo where it just does console log error, right? Nothing complicated, nothing well structured or well thought out. But yeah, if you swallow your errors and never put it out, then yeah, that would not be detectable. But
so this is the workshop,
so we just ran through a demo of what our cloud product is. So we just stood up an entire environment with an internet endpoint and deployed a blueprint into that. Yeah, I know, it was only 17 seconds, it was a bit fast.
But it's impressive, and I'd like to play with it.
And so and we do have, our workshop product that, again, you can download and use today, is identical. In fact, it's a little dangerous how identical the local development environment is to the cloud environment. Like all the logs, everything works the same way. So you can, if you're a fan of the 12-factor app and you remember, I forget which factor it was, they promoted the idea of local dev parity, or I'm sorry, dev prod parity. We think that local cloud parity should be a thing. So, that ability to like quickly get up and running with development, especially once you get past a kind of a non-trivial app. If you've got like one Python service you're running, okay, you write a README and you put it in your repository, and you end up like writing in a README, make sure you have Python 2.7 and run this to set up a virtual env, and you have to like tell people all these details of how to get this Python code running locally on your machine. Maybe you have it in a container and you can do a Docker up, right? But like apps are more complicated than that these days. There are multiple services and multiple frameworks and multiple languages with, backend APIs and front-end web services and administrative tasks and databases and all these things. And, I'll try to be subtle about my disdain for Kubernetes. But like Kubernetes does not, does not adequately address that, because running your running environments of your software are more than containers, right? Like they are, like containers are great. They're the best build, kind of runtime artifact we've ever created, in the industry. But like running a whole application is more than that. It's DNS names and certificates and load balancers and databases that need to be backed up, and like it's so much more than containers. And if you try and like shoehorn a complex app into containers, you're gonna have a bad time. Cool. Any other thoughts, follow-ups, questions anyone's got? Cool. Well, it looks like everyone is sufficiently pizza and beard. We can just jump into the next one. So let's get into the AI demos and talking about this. So now that you've seen Noop and you know that we have the data, like that's the key part I wanted you to walk away with that last section, is that we have the data for an LLM to understand what is going on with your running software. That's something we think is extraordinarily unique, and good luck to anyone trying to DevOps their way through that. So let's talk about deployments and changes. So when you change your code, it's inherently risky, right? It's change is always inherently risky. And, as an industry, we've developed and kind of grown over the years varying degrees of robust risk mitigations to try to make it so when you change your code, you don't break production, right? Like that's the goal. Nobody wants that to happen. So we do all these things like, did it work locally? Yes. Did it lint? Did it unit test? A lot of these types of things are very limited, and they can only catch kind of known and known problems, or problems that are exercisable by the person that like can, like you have to expect them, right? If you break something in your code base, but then don't exercise it when you're locally developing it, or you don't have unit tests on it, like nothing will notice it. You can have other developers try and review it in a pull request. You can, go through all the scans you want. You make sure it compiles. You can, get fancy and do more complex integration testing. You can deploy it and have it do health checks to make sure that those services are healthy before allowing it out. But I have a feeling many of us have experienced varying degrees of robust systems like this, where they have made a change and it gets all the way here, and then something breaks. Some unforeseen degradation, some performance impact, some unexpected behavior was introduced by your change. But hey, it passed unit tests, right? And we thought this was a really interesting place for the application of AI, because again, like these are all the detectable kind of, you have to know these things in advance to check for them. And like, so what happens when some unforeseen problem spits out of your application? Like, how do you, detect that? How do you prevent it from getting to prod? And I feel like, especially if you work in any kind of large scale, software shop, like, after you do deploy, everyone kind of holds their breath for half an hour and watches the logs and keeps their eyes on the dashboard to make sure that nothing broke. And that's kind of silly. So we thought, why not have an AI do it? So we thought through how can we leverage our unified understanding of the data of your running software that we have, this whole contextualized history, to do that for you. So here's first diagram of one of our prompts and what this looks like. So I'll mention we're currently using Claude 3 as our backend LLM. They have a nice 200,000 token context window, which is very advantageous for us. When we started playing with this last year, and like we're playing with, I think ChatGPT, like the limit was like 16,000 tokens, and I think we could fit like somewhere around 15 log lines in that. It was not enough to provide kind of useful information. And so we've, a large part of our exploration into AI in the past months has really come down to us understanding that, like, we are not foreseeing a situation now or in the near term where you can AI all the things. Like, we don't see it being financially or performance that in a state where like we could just run every log and every single thing that happens in your environment all through AI all the time. So the game really becomes, you've got this limited context window with an LLM of what you can ask it to do, what you can ask it to analyze. And we've, it's got this little window and we've got this much data. So how do we optimize for the most relevant, concerning, interesting data that we have to fill that little window to, and we expect this window to grow over time, like Claude, Anthropic says Claude 3 is already capable of 1 million tokens, so it's going to go 5x there probably this year. But like, we focused on how can we go from all the data that we have about how your software works to what can fit inside of the LLM to ask it to reason about what's going on. So we started with, we built some of our own internal tools to kind of help us streamline this process, to create prompts, to attach context to them, to stream logs in, to sort through and find the most concerning logs and try and fill up the context window with the most useful information. And so what we're going to, and we'll demo this next, you're going to see, we're going to do a deployment, and we're going to see Coop, our cooperator, keeping an eye out for you. And what it's doing every time is that we're sitting there looking through, we've got the blueprint, so the architecture of your application. We've got the deployment workflow itself, where the deployment state is right now, what's going on with it is passed into this. And then the most interesting one, I think, are these two with the environment logs and the monitors, where because of our highly contextualized information, we can pull out and ask, when you do a deployment in an environment, we can pull out what were the monitors and logs and everything going on for the 10 minutes before your deployment, and then the new stack that is being launched by your deployment, filter down to just the logs and monitors from that, and pull those out separately. And so what we effectively do is ask the LLM to compare them. Because if you just detect a problem and try and roll back anytime you detect a problem, like what if you already had a problem and then tried to do a deployment to fix it? It would think that it should roll back. So it's all about this comparison of like being and having that data structured enough that you can actually answer the question of how was this environment doing before the deployment to what has my deployment done to it? And then ask the LLM, has anything really screwed up here? So so cooperators saying they're constantly looking through this. We run it through, every time you see the black box is a prompt. So we run it through our analysis prompt that aggregates all this contextualized information, and we do that analysis. And then we just started using, if anyone's into Claude and Anthropic, they just released tools like 3 weeks ago. Been scurrying to play and implement that. It works okay. And we've basically given the deployment observation analysis these 3 actions that it can do. So as Coop is checking through your environment during your deployment, it can give you a report and say, this is what I'm seeing going on. It can suggest a rollback. Now, we haven't implemented this where it automatically rolls back. We think this is something where there should be a human in the loop. And then we have the ability to diagnose a failure and try and help you understand what went wrong. So let's dive into it and play. Window, here we go. So we've got our running app here. I've already kind of prepped a little bit here, and we've got some builds that we know are going to break. So let's start with the broken build. And so we're going to go through and do a deployment here. It's just telling us what changed, just the build, and we can go watch the deployment happen in real time. And so we've got, kind of overall status here. Here's the workflow that was mentioned. So this data is being passed in for analysis. And then we've got the, a little bigger. And then we've got Coop over here on the side, keeping an eye out for you. So Coop is just did its first check. It's got an issue with the chat API service. Okay. And so indicating a non-zero exit code, by the way, like live AI demo, so anything could happen. So let's see, might suggest putting some blue in your pizza sauce. Okay, so yeah, it's detecting more that we're seeing this. Now, normally I can click this button and open the logs. And that's usually what we tell people to do when things start breaking is look at the logs. But the point of the AI demo here is that Coop is looking at the logs, so I'm not going to do it for you. And we'll see it's going through here, and right now it's trying to scale up. There we go, it failed. And at this point, Coop's going to kick in and try to diagnose the failure, again, with all that information that just happened. There we go, we've got root cause is service instances are failing to start and stay running due to multiple errors. Multiple containers were launched, but all exited with non-zero status codes indicating a problem. Logs show a reference error being thrown, suggesting there's an issue with the application code. And we can actually click on the suggestions here and see Coop give a little breakdown of you should look at the code for your chat API component. Look at index line 7, ensure it's all functional. It gives a lot of detail there. And just to show you, we can actually look at the logs here. And let me shut the window on that. And so these are the logs that were going on in that newly created stack from that deployment. And so Coop not only kind of saw containers start, and we can click here and see our error where it's telling us you recognize a JavaScript stack trace output, just good old unhandled error spit out. Okay. And so not only that, and we can let's filter down here real quick just to this this specific container. So we can see one container here. You can see it started, provisioned, launching, verifying, and then it crashes instantly. Exit code 01, and it's exited. So what we try and then do, and let me filter that down. That filter. Cool. And so you can see it basically is repeating. So during the deployment, we tried to launch the container, it crashed. We tried to launch, we back off, we try again, it crashed. We tried to give it time to come up and become healthy, and it just never did. So out of that information, we can see this is where Coop caught all this stuff. If you want to see what my error was, let me switch branches real quick to broken. There it is. Just type foobar in, and so that caused the application to crash. That caused Coop to that caused that loop to happen, and then Coop could see all those logs and reason about what was going wrong with that deployment after it failed, right? So I mean, you can actually even see we've got a this is how we've traditionally done it, is when your services fail to launch, we just say at least one of your service instances was unable to reach a healthy state. Read the logs. That was the best we could do before, was it didn't come up. We don't know why. We've got all the data. We can't tell you exactly what happened within the data, but you can look at it and figure it out as an engineer. This is where the AI really kicks in and does that part for you. So, so this is kind of a very, Baroque and direct kind of example where it just hard crashed, right? Kind of easy to detect, not that impressive. Let's do another one. back here and let's trigger another deployment and let's do my damaged branch that I've got going here. And so we're gonna just change builds. And so it's going to go through again. And now this time I introduced a bug in this code that does not cause it to crash. All those risk mitigations are going to pass with this code, but it's going to crash. It's going to fail on every request to it. And so we're going to see it going through, and it's okay. The deployment's done. It completed, right? But Coop is still watching. Coop is still sitting here on the side, keeping an eye out for those unforeseen consequences that can emerge. And holding my breath. Still hasn't detected it. Let's, oh wait, do I have my my polar on? I need to actually generate some traffic to cause the crash. I've just got a little script here. Yep, there we go. It's okay. So so we can actually take a look real quick and see those logs coming out. Now you see every time there's a traffic request, I just typoed and removed the P, and now it says romped is not defined. And so as Coop is watching that, it should detect that that there is now this that there is this degradation in the environment that did not exist in the logs before this deployment, but now do. And yeah, worth mentioning real quick that like we do, our standard deployment is a full blue-green deployment. So we kind of have, your current blue stack is sitting there doing its thing, and we launch a whole nother stack, bring it all the way up to healthy, make sure everything's good, and then we cut traffic over to it. So it should, and Claude didn't pick it up this time so far. So that was fun. Let's try once more and see if we can provoke it. Like I said, anything can happen with the live AI demo. So yeah, we've definitely kind of been experimenting with the prompt engineering here. Like I said, with Claude came out with this new tool support just I think 2.5 weeks ago. And it's interesting. It helps like bring some structure to telling Claude like here's specific things you can do. But if you have any experience with any of these LLMs, like they don't do well once you start giving them lots of direction, especially when there's any kind of conflicting direction. And like multiple steps and multiple things. So here we go. We've got it detecting. Okay, good. So we've got it detecting deployment 4, introduce some issues where the chat API component is throwing 500 errors. And so that's not even anything you particularly had to do. We're your load balancer, so we're logging the 500. So that's automatically there. And at this point, you can see that it's recommending that we roll it back. So this deployment finished and this code is out. And now if we go over to here, we're getting errors. So being able to catch that this unforeseen impact that happened with your deployment after the fact, after the deployment's done, we're going to make this configurable that you can tell Coop how long you want it to watch after a deployment for any kind of problems. But yeah, it basically does the rollback. We can click here and it'll just roll back for us to the previous healthy state. And we can and we'll basically see those errors start going away in the logs here as the new code is launched. Cool. So yeah, so that's one of our first use cases that we think is really compelling, that we can build on top of everything we know about how your software is running, that we can just we can detect unforeseen side effects from you making a risky change, or any change is risky. So being able to kind of catch that and
Sure,
I
well,
can do it. Let me switch back. Sorry, I have to two monitors here. Cool. So yeah, with that, we'll take another break, but I'm happy to answer any questions about AI deployments. Again, feel free to stock up on pizza and beer. Yeah, Melon, anything I missed there on that end? Or if
Great stuff. Do you have this running on the environment yet?
so, I mean, we've been working on this just for the last couple months of adding all the AI stuff. So basically anything you see about Cooperator is not released yet. So this is all dev stuff that we're doing internally.
So, Noop, right?
Yeah, Noop, the Workshop and Cloud are out there. You know, Cloud's in an invite, wait list, so you can go, but Workshop is available to use today, free forever. We've got Windows and Mac support for it. Yeah. And the no, I mean we're running some startups, some internal things on it. We're looking for our cloud product. We're looking for people for basically early adopters that we can bring on board to use cloud. So if anyone has any use cases or anything, especially towards the end, if you're interested, yeah, we could definitely fast track some people off the wait list if anyone is interested. But yeah, Workshop gives you a really good idea. Again, like we literally reuse the UI from cloud to build Workshop. So you see the same kind of primitives and elements of you have local environments that have, builds and logs and all these same things. So it gives you a really clear understanding of it.
So now that you have the visibility into logs that got the proof to see, using it obviously for operational issues, have you trained it to answer pricing issues, cost issues, as far as resources, cloud resources?
So that's interesting. So
use case would be trying to be competitive.
Mhm.
You can't have so many costs.
Right.
Keep control. So how do I run an application lean? So if you could, I mean, almost free. Have to get.
Gotcha.
So how do you?
So yeah, I mean that's something that's one of our 12 expectations is scalability. We think that a good developer platform should scale with you from kind of trying to keep it real lean and mean on with your kind of early dev days, and then be able to scale up with you. So on that kind of lean end of it, we've got a lot of strategies that make it very competitive to keep your price down. We basically are very usage based, but we also aren't trying to we're trying to make, usually the cost overruns with cloud tend to happen because, I don't know, people, don't understand the implications of what they're doing. So we do want to make, we actually have really good, usage, kind of cost usage data broken down, down to the individual kind of component container level. So you can analyze the cost of your whole organization, your application, your environment, down to a single container. How much is this thing costing you? And in terms of trying to keep costs down, I'd say like primarily stay away from, there are some things that are inherently expensive, right? Like MySQL databases are always more expensive than, a lot of alternatives. And then, we have a lot of strategies with things like we have sleepy services. So if you have services that if you have dev and staging environments, we can make it so the containers go to sleep if no traffic has hit them for 10 minutes and only wake up again when traffic comes in. So if you have infrequently used environments, you can do that. Another practice we really like, and I can show real quick, just the whoops, I'm on the wrong screen again. So you can set up for your application pipelines. And so pipelines, you can do pipelines that are kind of basic build and deploy, right? Like on push to branch main, deploy to prod, easy peasy, right? So we integrate with your GitHub repositories, we receive those webhooks, we automatically do all that type of stuff. But the really cool one for cost savings is ephemeral environments or preview environments. So being able to, kind of break out of the traditional paradigm of having like a dev test prod environment running 24/7, have a prod environment, and then have every time that you create a pull request, automatically launch a preview environment that lives for the lifespan of that pull request. So like there's things like that, I think that are probably the biggest things you could do to avoid cost overruns.
Ну давай мячик, давай сюда, давай папе мячик.
Okay.
Give me the ball.
Yeah. Mute this. Okay, cool. So,
Давай уберемся.
again,
Для начала. Потому что будет грязно, мама нас будет ругать.
okay, and
Не хотим, чтобы он нас.
let's just quickly deploy back to our,
Давай, get the ball. Get the ball.
okay, to our base branch. Cool. So yeah, let's go back over to our deck and let's talk about that one. Okay, so next use case is what we're calling AI triage. That's why I think it's pretty cool. I'm really excited about this because, like, as someone that's worked in data centers and operations and all kinds of things and been on call and, you know, I don't like getting woken up at 2 a.m. when alarms go off. And, you know, often that not only happens, but like happens for dumb reasons. Like it happens because, you know, trying to filter alerts and alarms is hard, right? Like it's a signal to noise ratio problem of how do you kind of pull out what is useful to you out of this enormity of noise about what's going wrong with your environment. Again, if like you detected 0 errors occurred and you register that as an error and you alert someone, that's not fun for that person. Has to triage that. We got to thinking about what could an AI do for solving this problem? And so we go back to, you know, another lovely diagram here with our black boxes, and we're still really kind of massaging the primitives and the data structures here a bit to figure out how we want to do this. But we started with this idea of problems and incidents. And we decided that problems happen all the time. You know, like, but not all problems are incidents. Incidents are things that require timely human intervention. Problems are something might have gone wrong. Something indicates that something might have gone wrong. And like, you don't want to, as a developer, have to answer that question every time. So we normalize the idea of problems and we aggregate, and I wish I put this on the diagram, but we take in these ideas, we take in when alarms happen, when people report problems. We run it through the AI here. And so you can see we start with the problem. What problem are we triaging? And then we take all of the logs out of that environment that's having that problem along with the monitors. This is a good spot to mention concerns, because this is something that we implemented to help us kind of answer this question of like, we got this much data, how do we choose the most interesting bit to put into the LLM? And so we take these types of every event that's being processed is being scanned and looked at for concerning situations. So here we've got, I mean, this is kind of a simple one, right? It's just saying this contains the word error in it. So, you know, effectively, like, think about like when you have a problem and, you know, if you're a developer or an SRE going to investigate, you go start like skimming through your logs, right? You start filtering out all the info events and trying to get down to like, you know, what are the concerning things happening? And you're looking for that novel error that you've never seen before, just whatever the hell is breaking your app. So we implemented this idea of concerns that not only we have a common concern list, so we populate all the common things that an SRE would know, right? We see 500s as bad. We see the word error as bad. We see, you know, your database running out of space as bad. Like, we detect all those common things for you. And then we implemented the ability for you as the software developer to add those concerns to your application blueprint. So you can express in code software domain specific concerns. So like when your app outputs this log line, like, you know, billing report failed, you can explain, you can basically document that in your code. When this event happens, it's a problem, it's concerning, and you can even give advice about what's going on with it. So like, think about cases where how many times have any of us tried to launch something that ran on someone else's machine and it doesn't on yours, and you ask them why not, and they say, oh, I saw that error before, you have to set this thing, and then it works. Now you can document that in a way that is automatically discoverable not only by you, but by the AI. So all of those problems, the concerning logs, the monitors, all that information is pulled in as a problem is surfaced. And first we run it through, this is just, you know, a little interesting AI bit here. We've noticed we originally tried to do this as one prompt and it did not work well. So, you know, we've gotten into some prompt chaining to try to break these more complex tasks into discrete individual tasks that kind of feed into each other with Claude, because if you give it a lot of tasks, it might do some of them okay, but it often will just miss things. So we basically run that kind of source data through analysis, and then we get the output of what the AI thinks is going on with this problem, and then we take it and add that analysis with everything we know about open incidents, and everything we know about, and all the directives, and we'll get back to that. And we take all that information and we take these pieces and run it through triage, and we run a second prompt where we ask the AI, okay, given this problem with this analysis, with these other active incidents going on, triage this problem for us. So when an alarm goes off at 2 a.m., it's a problem, gets all the way here to triage, and then Coop can decide what to do about it. And we got the actions here right now for incident, create or attach it to an incident. We're gonna show that. You can escalate it to a person and say, I don't know, this looks concerning. Doesn't need a timely response, but a person should look at this. And then you can just straight up ignore it. And Coop can decide this alarm isn't a problem. Don't wake anyone up. So let's take a look at our operations center. So going back here to Watson's organization, we can take a little look at our organization our operations command center. And we've got a little bit set up here where we already have this idea of monitors. So if you're familiar with any kind of traditional monitoring, right? Like you have metrics of data points that if data point for this long goes over this number, it bad, sound alarm. Those definitely have a place, right? They're definitely like kind of known thresholds of damage and problem that you want to explicitly detect. So we have that for monitors, but monitors aren't a good fit for everything, right? Like if you try and monitor everything that could go wrong or detect everything that could go wrong in your application with metrics and alarms.
Hey, could anyone else on the call?
Because there's just not enough expressibility
please.
of things. You can all,
I'm just,
when you're in monitors, you're in a space that's very discrete known conditions. Oh yeah, I should trigger this down.
What's creating a free
So
I got these.
let's go over here. This is the ChatGPT API key that our app is using, and let's delete it.
And these ones are
See what happens.
good ones.
So OpenAI takes 2 to 5 minutes in my experience to actually revoke the keys. Let's see how long it takes.
Peanut butter,
so
strike
the,
down.
I'm talking here, we can see, let's dive into monitors a little bit and see,
Okay.
we've got a few
Right.
set up here for
And these
yeah,
are
error
peanut
rates.
caramel.
You can see the history of
I see
how
quite sure.
it's going,
You.
and we can even break
No.
down and just see, little in the weeds, but we can even break down and see like what it's monitoring for in logs, like what data is it querying out of the history of your
Okay.
software, and then
Yeah.
what are the alarming
It's
conditions?
viewing, it's basically right now,
In this case, we're pulling in all the 500s
AI
and
week
all the
in
requests,
New York.
all the
Tomorrow I'm gonna go
responses,
to
and then
an
we're
event.
just
Oh,
Can you please
dividing to
yourself?
get the percentage
Yeah.
of what percentage of your requests are, what percentage of your responses.
Yeah, perfect.
all right.
And then we
Very cool.
say if it's
I'm just completely worn out.
it's a
Me
problem.
too, I
It's an
wanna
alarm.
chill.
Yeah.
I actually worked out this morning at 6:30.
And so, Noop we've had monitors for a while. It can sit there and it can check for those conditions. Again, if you have anything like an
I had
explicit
a very
condition,
serious
it's not just
conversation
our
with
logs, it's your
Mark.
logs. So if you have a log that outputs something that is a
And,
known problem for you, like the billing
They
report failed,
basically told me
like, you
to
detect that with a monitor and it
handle
could
it.
alert you. It could register a problem that could then be triaged,
out
that
what's
could get
going
to an
on
incident.
with
So,
and they
that's
said whatever
completely
you need,
available.
tell
Let's
us.
go
and
back
we'll
to the
get it.
operations center.
but, we need to help her.
And we're gonna see, once
Yeah,
that
Ruby wants
trips.
to go to another
Go
funeral
over here
because
and
it's
see, are
really
you still
going on.
Listen,
alive?
Yeah,
yeah, I
yeah.
think so,
so
Uh,
tomorrow, night, I'm gonna call Juic.
yeah. If you need me, I'll be here by Friday evening. I'm gonna go.
Stay there.
So,
It's serious, and I think she's afraid she has cancer. I think that's what she's afraid of, and that's why she doesn't want to go to the doctor.
I see. Well,
She fell down the stairs on Saturday.
yeah, yeah.
okay, no blue, good, okay,
Okay.
so,
So Mark and
see, as that goes, and we can also take a look here,
task force for her. And so
we had actually
we're gonna try to-
detected some of these problems,
I told
these
her
were
I'm
actually
gonna
happening
come to
while
her
we were doing the
house
earlier
right
demo.
now.
So.
What
it all-
Joey can say, look,
I'm gonna call him tomorrow morning. I
yeah.
don't wanna call him now because he's probably laying there. dead.
Let's go over to the environment. We'll actually start seeing, oh, there we go. We're getting, errors are coming out now. So we're starting to see
I'm just gonna call him and see
ChatGPT,
what is
you
going
know,
on.
we're just using the
Yeah.
OpenAI
Give me the whole
SDK and
truth.
Noop. And we can
Please
see
tell
it's
me
starting to
what's
just
going
throw
on.
errors.
Do
Again,
you
we just
or-
console log error,
Give
nothing
me
fancy.
anybody's-
And it's dumping these, saying our key is bad, giving us all the details, all this information is here. So let's go back over here and see, it should take about a minute after that starts to be detected. And so we're going to see it run through a workflow where it's going to sound the alarm, which doesn't alarm you. By the way, you can, if you want to get alarmed, you go here and set up notifications to directly be alarmed. But once that alarms, it will generate a problem, and then the triage AI kicks in and it starts analyzing it. There we go. Alarms are sounding. So we've got our error response rate is going off, and we can see it's triaging and it's open. So we can see it, I left an incident open from that previously, but we can see Coop went ahead and already, it's and so it went through the environment where that problem happened, and it found, basically telling us that suggests an issue with your API configuration. So, oh yeah, there we go, invalid API key. And so in this case, and just to go back to our diagram quickly, we can see, after that process went through, it triaged, it decided this is part of an open incident. I'm already seeing this problem. And so it attached it to the incident. And now we can see this incident history, and this incident opened earlier when we first broke it. And then it attached this next incident to it. And so now that we're in an incident, and this is like, out of the 12 expectations for developer platforms, number 11 and 12 are this. Number 11 is discoverable problems. You as the developer of your software should be able to easily understand what problems it's having. So that you've got that right here. Here's all your problems that are flowing through. And then the 12th expectation is inclusive incidents. We think that when your software is having a problem that require, that the people that make it are integral to fixing it. So how do you kind of marshal the right people and the right information together to answer that question, or to solve that problem? So we can look at our incident that's open now, and we'll see not only is Coop on the side here collecting information about what's going on, right? I can even go in and report a problem directly, right? So like alarms are a type of problem, definitely one way you know that you're having problems. Another way is people just tell you. People just start lighting up you in Slack or through your support that like, I can't use your app. So, I can just report a problem directly of I can't use the chat app, and trying a couple minutes, and we can attach that to the environment. And we can see the same type of thing happen, that Coop's going to take in that information, it's going to triage it, it identified it, and attached it to the incident. So it's basically taking problems as they're coming in and attaching them together to incidents. So think about like when you're actually having an incident, you might have a lot of alarms going off. You might have a lot of people reporting problems. Like it can be, you know, a little hectic when you're in firefighting mode. And so what Coop does is help aggregate all of this information down to you about all of the problems that are being detected that Coop, and like, you know, you're sitting here working the incident. So we've got a nice little chat over here for the team that's responding to the incident to discuss it while seeing all of the insights that Coop is tracking about it. Even as new things are breaking or fixed, like as alarms are sounding or clearing, all that information is fed into the incident. And then you'll also notice we've got another application of AI here. I didn't even put a diagram for this because it's kind of minor, but we use the AI to generate a summary of what's going on with this incident right now. So, you know, for you know, business or product folks that are that might be engaged in the incident, you know, give them some summary way without all the technical details of what's going on. And so we can see it's giving a kind of summary over here, and you can it's even feeding in information from the response team. So responding now, and it'll keep going through and updating its, you know, developers are responding now, right? Stored. And, you know, obviously it's just me talking to myself here, but you can imagine multiple people on your team, multiple developers engaging to all talk about this. And it's pulling all that information, all this, synthesizing it and giving that explanation. We also want to build like a status page thing so you can just give this to your end users. So your end users know when they go to see what's wrong with your application, you can get that output from it. They can report problems directly in here, right? Like it's great to be able to have your team, your customer support folks, be able to directly register a problem. But like you know, where I really want to get to is your end users report problems. And that's fed in here and can create that kind of element. Yeah.
For like ingesting that kind of data, like is it still entirely manual or do you have like integrations to monitor like a spike in Zendesk tickets?
Spike in Zendesk.
Like users, like,
oh,
like
okay.
your end users problem, like they have, would the only way to be you can pull that data in is like through your ingestion point, or is that something where like you can use other tools to be like you're already collecting user feedback from certain
Gotcha. Yeah, no, that's interesting. I mean, there's a couple ways you kind of handle that. You might have to like write your own task that just like queries Zendesk and publishes the problems on an interval. That would be totally doable. You know, we kind of want to collect it directly though. So that's kind of our goal, is to have this direct feedback between your end users and when there's an incident and the people fixing the incident. So, you know, kind of how that fits into an existing ticketing system is kind of interesting, but we haven't thought that much about it. Sure. Yeah. And again, there's kind of like, you know, being able to communicate to the end user about not just like that they're having a problem, but like, you know, then I think we might be able to, in the long run, build some more compelling experiences for end users than Zendesk can, and be able to, you know, have, you know, Coop providing back directly to individual users what's going on and giving them status updates. So yeah, but I mean, you know, integrations are something that we, like, I think is a little manual right now, but like in terms of like, you'd have to write a little bit of your own glue. We don't like you having to write your own glue, but if you want to, you can. Cool, and okay, so let's fix it now, right? So we've got a problem, it's open, it's been open. So let's go over, so we've got this incident. Let's go over and jump into the associated environment and let's go fix our API key. So, whoops, someone accidentally deleted it. So let's do. Oh wait, let me do that. Okay, so we've got a new key, and all we gotta do is go back over to Noop. We're going to update our environment variable here, set it to the new value. And it's going to tell us we got to deploy it to make that new value take effect. And so we'll just keep the same build, and we can see all it's going to do is change the, it's going to give us a summary. Only thing changing in this deployment is we change that variable. and let's go back over to the operations center to watch what happens. Okay, so Coop's already on it. So we can see the history that, so it detected, and analyzed the problem. It attached it to an incident. Now it just noticed the deployments happened in the environment where the problem is occurring. And we just gotta wait a minute here for alarms to clear and pass. Yeah, I'm gonna stay on this page. And so, yeah, what Coop's gonna do is notice that the monitor is then cleared, close out that problem and report that back to the incident that everything is closed out. And just for fun, let's do a while we're waiting on that to roll through the monitor time. Let's do something silly and just let's have, I want a taco. Report problem. See what happens. Live demos are fun. User wants a taco, but it doesn't. Oh, it did think it was related. Okay. So detach that one. So let's see if we can provoke an ignore. Yeah, another thing we've noticed with a lot of the kind of work on this is like the AI kind of always wants to be a good boy and like answer, even when it doesn't know what's going on. So so it's decided to just watch this one for now. So actually, let's go in. Let's talk directives. Oh, there we go. So it did finish up. That was problem 3. And so yeah, so after it back here, after it attached to the incident, after it noticed the deployment going on in the same environment, now it noticed that the monitor cleared, that the alarm cleared. And so it gives you this nice timeline of this problem that it, and you can see it took 10 minutes to clear overall for us to respond and clear this. Yeah, kind of the one last little thing here in this arena to show is let's go back to our environment. And yeah, this is very early that we're playing with this, but just wanted to kind of share we're thinking about this, that we have a settings page here for Coop. And like, how do you customize the behavior, right? Like, how do you customize the cooperator's response during triage in like, if you have kind of oddball scenarios, right? Like if you have, if some problem comes out of your logs, saying this, if like Coop detects something complaining about you haven't upgraded to this version of this SDK and it's deprecated and you should do it right away, right? Like that's a detected problem, but you might be fine with that old version of that SDK. So how do you tell the cooperator to leave me alone about it? So we've been playing with this idea of basically giving you a way to inject your own, it's an LLM, so it's just language. And so being able to inject your own customizable directives for Coop specifically about this environment. So we can say, ignore people. Okay, we'll give it a directive, and I just put in ignore people with opinions about Coop's mascot, and we can put in it's a very contrived demo. I don't like that cooperator is a duck. It should be a goose. There we go. And basically that directive is just included in the triage process, saying, this is something, and that the developers of this environment, like this is your direction from them. And so you can see it, problem is that user does not like the cooperator as a duck, they want to be a goose. Logs don't contain anything relevant. And it says developers have provided a clear directive to ignore any opinions about cooperator's mascot as this does not represent blah, 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 and it ignores the problem. So that's something that was a submitted problem that never bothered you. So yeah, that is where we are at with our operations center, and what we're thinking about with triaging problems. We think this is, again, like something usually like trying to have 24/7 coverage to maintain uptime of your software requires more than one person usually, and people that aren't happy when they get woken up in the middle of the night being paged. So, you know, this is really the goal we're chasing, is how can we use AI to short circuit that entirely. I mean, there's obviously still occasionally problems that really require human intervention, but if, you know, we want to use AI to handle that signal to noise ratio problem for us, because, you know, when you could have alarm sound that you're, you know, high on, you know, you're using a lot of memory or your CPU spiked or anything like that, but that doesn't mean that it's requires waking someone up or that there's a detriment to users. You know, it's information, it's something problematic, but not necessarily an incident. So, you know, having AI being able to filter through all this and be customized by you to fit your specific software needs is what we really think the future looks like. And, you know, you don't, you know, very, very rarely, only when absolutely necessary ever get paged. So, yeah, I think that was the end of that section. So yeah, I'm happy to answer any questions or anything anyone's got about our operations and problem triage. I mean, I don't know, I'm curious if anyone has any thoughts about how they might be able to leverage it, or like what's missing, what would you like it to do more?
I think the interaction with that.
Yeah.
Especially being able to attach. It's you can describe things in different ways, and just being able to go, you guys are talking about exactly the same problem. I don't have to think about. I mean, yeah, just that.
Yeah, I mean, no, it's a really hard problem, right? And especially when you have like multiple vectors, right, of information coming in. Like sometimes, you know, maybe you have support and they're filing a ticket, or maybe it's in your CRM, or maybe they just Slacked you something or emailed you something, or like, how do you kind of, you know, aggregate these things and make them make sense? So we think the most direct way to get to an end user is a status page. You know, to kind of, you know, that's kind of our next frontier we're really interested in with all this operation stuff, is we've got this idea of your organization is monitoring these things and may or may not have incidents open, and, you know, and so like being able to kind of put that directly to your end users as a status page and have bi-directional communication about the health of your service is like, I think, yeah, I think there's like so many cool possibilities there. Cool. Yeah. Got another thought?
Just maybe I missed that. These can deploy pages in any cloud service or in a specific cloud service.
So we run our own managed cloud on top of AWS.
Yeah.
And so, you know, if you're interested in Noop Cloud, we offer a fully managed version where you don't have to do anything and you don't have to have an AWS account, and we just take care of everything for you. And we also offer a dedicated cluster option where we can you know, give you a dedicated cluster where, you know, you get isolation of your own compute and data, and you can even connect it to your other network. So if you have like pre-existing, you know, investments in any kind of, you know, ways that you're running software, if you've got a few big, you know, VMs running somewhere that you've been carefully managing for years, right? Like leave those where they are, stand up your own Noop cluster, connect the networks to them, start doing all your new stuff on Noop with all these modern capabilities, and be able to connect to your existing you know, systems. Cool. Yeah. Any other general thoughts, comments, questions?
Has someone had to dig through logs before that you can all the way to
Yeah, I mean, it's an annoying problem, right? Like, especially once you get to scale, like trying to filter through logs is always kind of a challenge. I mean, usually most organizations we've worked with in our consulting experience, like have lots of dedicated people just sitting there tuning those things. you know, like trying to filter out the, you know, the signal to noise. And yeah, that just like leapt out at us as like, you know, like an obvious use case of LLMs was to like, you know, like again, this like semi-structured information in logs that like is nowhere near predictable enough to like actually try to write conditional statements for, but like it does a decent job at it. We expect it to get better and be able to handle more. So, you know, that's why we kind of went ahead and started investing in this direction.
Especially like multiple users do multiple requests at once, and you know, maybe there's a log that hits another point later on in the chain that someone else is doing something at the same time. So yeah.
Yeah, that's where like having that ability to like cleanly discern like, you know, which, you know, like while deployment's going, you've got old containers running old code, new containers coming up with new code, and like how do you, you know, separate that? Usually, you know, you have, I mean, in my experience, it's only some of the most robust, very well invested DevOps organizations that come close to being able to like tell you like when you see two different logs in your log output, like this one was running this build and this one was running this build, right? Like, so yeah, like that's where having that data is like probably the hardest part of all this. Piping into the LLM is relatively simple to like actually understanding what's going on with the application.
That's an interesting point that you said, as far as producing the, you know, the right events that you can ingest. So the cooperator in any of this, you know, so cooperator can only respond or actually analyze information that's in this. So it has to be, and so if you're going to be hosting the environment, how do you set up the logs? You know, and what
Yeah, you just output anything to STD out. We capture it and analyze it. And again, like we'll catch the simple things like, you know, those unhandled exceptions, right? Like that was not intentional or structured output, but you know, Node.js does that by default when it sees a reference error. But like if you want to do something more intentional, it's really easy to just console log some JSON and output some structured data that like, you know, like is describing how your like what, you know, the actual business of your software, not just the infrastructure around it. And yeah, I mean, we just thought that was kind of the, you know, most you know, most tools in the observation space require a lot of upfront investment and thought in those things. That like if you want to track metrics, like, you know, you have to you know, write time series data explicitly every minute to something that you want to, right? Like we can just, you know, we can pull metrics out of your logs. So if you just want to have your software, you know, every time that that someone clicks checkout in your cart, you write a log saying, you know, event customer checkout. We can easily then pull analytics about how many checkouts have there been over time. We can draw graphs about it. We can monitor for it if it goes too low, if they're, you know, like all those things become really available. So like we thought that was a really important part to like normalize everything into one thing that tells the story of the history of your application. Like if you're kind of explicitly having to you know, either set up metrics and publish time series data, or if you're like, you know, using something like Datadog or something where you have to like explicitly tell it like what data to index and what fields you have of what and what you care about. And like, you know, it's just so much work that most people don't do it. Cool. Yeah, any other thoughts anyone has? Yeah, what's up, Mark?
You brought up some of the tools, and that's relatively new, right? And you talked about reporting, there was the rollback, and there's one more. Do you have any other like future state thoughts on what tools might be coming down the pipeline? Something like maybe make DRs and relaunch an environment and see if it fixes? Like, is that something that is given thought to yet?
Yeah, definitely. In fact, that's you know, we've given a lot of thought to like what I'll tell you, like one thing is that like we already try to do that, right? Like we already try to automatically like not we try to automatically stop you from getting in those types of situations where like, You know, our blue-green deployments automatically kind of have all these things in it that you know, catch and roll back things, right? But like, so like, you know, we've definitely thought of some like explicit ones that like, you know, like basically most of Noop doesn't require manual intervention, right? So but there are a handful of things, for example, like, you know, if you have a SQL database, you know, that has a fixed disk, right? Like we've already got, we already, since we're running that SQL database for you, we're sitting there generating logs about like every minute telling you how much, you know, free disk space you have and, you know, what the IOPS are and all that type of stuff, right? So like we've thought about cases where if we detect that your, you know, we can detect a concern that your free disk space is below 10%, and then we could have an action that is ask a human, you know, human in the loop, ask for permission to increase the database size. Like the only reason we don't automatically do that is because it costs money and we want a human to approve it, right? Like it's not like that's an undetectable state for us to just go ahead and fix anyways. Yeah, we've thought about that. We're interested in some ideas around like security and you know, kind of like CDN DDoS type prevention stuff that like as we're analyzing problems and see in the logs specific IP addresses appearing a whole lot or something, being able to take a remedial action like block it is something we're thinking about. Is there anything else, Milton, on the radar we've been talking about?
I think, scaling
Oh, yeah.
applications up and down is another use case. Like, auto scaling's been out there for like 10, 15 years at this point, but it's not really smart, right? You could actually use LLMs to like really go deeper into what exactly your application is doing and like scale based on that rather than be like very simple, like binary,
Yeah, I mean the common approach to auto scaling, right, is like if CPU over N, it bad, add more. You know, CPU being high is an indication of something. It's not necessarily something that will be fixed by scaling. Also, there's lots of situations that might need scaling that don't surface as high CPU. So like, yeah, like that's something we're thinking about. Like, as such, we have not implemented the old crappy kind of auto scale when CPU above N because it's kind of old and we just want to figure out something better that like kind of more automatically scales. So yeah, like really trying to interrogate the state of of a specific service and would that service benefit, like is it in a distressed state that would benefit from more scale, is something we're thinking about as well. Yeah, any other kind of remedial things anyone can think of? This is like a really hot topic we're trying to figure out. Like anything else you wish it could do for you when it detects a problem? Yeah, right.
How do you gonna keep the feedback loop open?
Oh, getting ahead. Yeah, as far as moving forward, like we've got our GitHub page has our discussion board. You can talk to us, directly. A lot of our teams here and on that regularly. You can email us if you have something more personal you want to talk about your case. Yeah, that would be the kind of primary avenues right now. Anything else I missed there, Milton?